Okay, today's lesson's over solving right triangles. It's section 9.6 in the book. If you have a question about it, let's get started. First note page says determine which acute angle has the given geometric ratio. So we're determining if it's angle F or angle E that has the sine of the angle is 12/13. So 12 over 13 is here. That means it would have to be angle E because 12 would be the opposite side and 13 would be the hypotenuse. So it's angle E. The tangent of angle is 5/12. So 5 would be the opposite, 12 would be the adjacent. So that would be angle F because angle F has an opposite over adjacent of 5/12. So that's angle F. Second part. Approximate the measure of the given angle to the nearest tenth. Since you're looking for the angle and we know what the ratio is, 0.75, we're going to do the inverse. So you type in the inverse of tangent, 0.75. Second, tangent, 0.75. And to the nearest tenth, it's about 36.9 degrees. Now, since you know what to do, then we don't even have to write this anymore. We can just do it. The inverse of sine, 0.87, is 60.5 degrees. And the last one, the inverse of cosine, 0.15, is 81.4 degrees. Okay? Next one, write the ratio of each as a simplified fraction and as a decimal to the nearest hundredth. So to do the first one, the sine of A is here. Sine is opposite over hypotenuse, so it'd be 15 over 39, which reduces into, remember how to do this in the calculator, 15 divided by 39, press math, enter, it's 5/13. Now just convert that to a decimal. You can either go 5 divided by 13 and then round it to the nearest hundredth, 0.38. The cosine of A. Cosine is adjacent over hypotenuse, so it's 36 over 39, which equals 36 divided by 39, math, enter, 12/13. Which you could divide it out, or you can go back to math, go to the decimal, and press enter, and it'll be 0.92. And then the last one, the tangent of A. Tangent is opposite over adjacent, 15 over 36. Reduce it. 5/12. Write it as a decimal. Go to decimal again. About 0.42. Now these first three things are all simple little things that you have to know how to do. Now we get to the stuff that's a little harder. This one says solve each right triangle. That means you want to find all three side lengths and all three angles to the nearest tenth. So when we look at the first triangle here, we know it's a right triangle, and we've got two side lengths given and one angle. I need to find the rest of it. The first thing you do, if you got two side lengths, is you use the Pythagorean theorem and find the third side. So that would be 2 squared plus 3 squared is 13. Then take the square root of it, and you get about 3.6. All the numbers you're going to do to the nearest tenth. So write it in a picture. So side C is 3.6. Now we need to get the angles. So I'm going to start with angle B, and I'm going to use my trig functions to get angle B. So angle B is what I'm looking for, and I've got opposite over adjacent, which is tangent. So the tangent And I shouldn't have written it like this. Let me do it like this. We'll say that angle B is our theta. So from this angle position, it's going to be tangent of theta is equal to the opposite over adjacent. Then switch, since it's an inverse function, because you're looking for the angle, switch it to the inverse. And then type it in the calculator. Second tangent 2 divided by 3 is about 33.7 degrees. So if we know that it's 33.7 degrees right here, then to find the last angle, you go 90 minus 33.7, and you find out that the angle A is 56.3 degrees. And you have found all three parts. We used the Pythagorean theorem to find the missing side, then we used the trig function to find one of the angles, and then subtracted from 9 to get the other angle. That's one type. The other type of solving the right triangle is if you're given an angle and a side length. So we cannot use the Pythagorean theorem because we're missing two sides and only have one, but we can find the other angle quickly by going 90 minus 25 is 65. Now I'm going to solve for h. I'm going to use 25 degrees and solve for h using the trig function. So from this angle measurement, 25, I've got opposite over hypotenuse. So that's sine. So sine of 25 degrees is equal to opposite over hypotenuse. X is on h is on top, so do the cross products. H equals 13 times the sine of 25. And I get about 5.5. That's the length of H, 5.5. Now I need to find the length of G. From this angle, I've got adjacent over hypotenuse. So I go cosine of G, cosine of 25 is equal to G over 13. Do the cross products, and G will be equal to 13 times the cosine of 25. So let's plug it in. 13 cosine of 25, 11.8. That's the length of this side. So we've just solved this triangle because we have all three angles and we have all three sides. So you're going to be using a combination of the Pythagorean theorem and the trig functions to figure out all 6 parts of each triangle. If you don't have any questions, then go to the back side and start working on your paper. Thank you.